Today we're going to cover 16.1 indefinite integrals. Okay, so let's get started. So before we even begin, what is integration? So basically integration is the reverse process of differentiation. So when you differentiate with respect to x, for example, okay, if I differentiate y with respect to x, okay, where y equals x to the power of 4, I get 4x cubed. Similarly, for the next two cases, you differentiate y with respect to x, you get 4x cubed, and you differentiate y with respect to x, you also get 4x cubed itself. Here lies the problem. Do you notice that if 4x cubed, here you differentiate get 4x cubed, but the source material, so to speak, or the original equation in y contains a constant that might be unknown to us. So for example, here quite clear cut, if I integrate 4x cubed, you integrate, which is the reverse of differentiation, you get x to the power of 4. However, you notice that here you integrate there's this extra plus 6, there's this extra negative 3. So what we will actually need to do here is actually to add in a constant. So we do not know what this number is, okay, we need to put in a constant. Usually the constant is called we use the letter c plus c, okay, and then when we do that, right, this is called an indefinite integral because we do not know what the constant c is. Alright, so now, okay, how do we integrate is quite simple. So if you think about it, we just use a simple case whereby y equals to x to the power of 4. Okay, what we will say is we power, okay, 4, okay, we multiply by the power 4, then you take x power minus 1, 4 minus 1 is 4x cubed. Since okay, so first thing here is number 1, okay, multiply by power, okay, or index. 2 is index, okay, minus 1. So if you want to reverse the process and integrate, so what we should have is index plus 1, okay, so instead of multiplying by index, we will divide by the power or index. Divide by index or divide by power itself. Okay, so now how does this work is this, here if I'm integrating 4x cubed with respect to x, please note the notation. How do I draw this symbol here? Follow me on screen now, like this and like this. One more time, integration is you have a little like U shape, inverse U shape there, and go down like this. This is integration. So I'm integrating 4x cubed. dx means I'm integrating with respect to x. So as I was saying just now, what I do is index plus 1. So x to the power of 3. 3 plus 1 is 4. So then divide by the new index. So I divide by 4. Notice that what I should get here if I simplify is x to the power of 4. So you notice, you differentiate, you get this. You integrate, you go backwards to get this. Now, there is something that we need to add over here. So I'm going to put it in peach color. Is plus c and plus c. So why do we need this plus c? I've explained in the previous slide. When we differentiate, okay, you get this. You differentiate, always 4x cubed. However, there may be a constant that we're not aware of. So to show our unawareness of what that constant could be, so we will write it as plus c to indicate that there is something called the integration constant. Okay? Okay, so now example 1. Given that y equals to x times x squared plus 6. Okay, show that differentiating y respect to x can be written in this form itself. So now let's begin. Part 1, we just differentiate. So we simplify first, make our life simpler. Why bother using the product rule when we can make our life simpler? So I get this, y equals to x cubed plus 6x. You differentiate y with respect to x is 3x squared plus 6. So if I integrate, okay, basically if I differentiate with respect to y, I get this. If you integrate, right, you should get back the same value. but more on that later. So they want us, so I factorize 3, I get x squared plus 2. So I've shown what they wanted me to show. Now for part 2, hence to find the integral, so I integrate 3x squared plus 2 with respect to x. Now again, differentiating, you get this. Integrating, you should get the same thing. So I can just write down that the integral will be x cubed plus 6x plus, don't forget that when you integrate, there may be a constant that we're not aware of. So what you need to do is to add in the plus c, okay, which is the integration constant. All right. Okay, that's example 1. Now, can you try it one by yourself? Okay, pause the video for a moment. It's really not difficult. It's the exact same thing as what we have just done. And do unpause the video when you are done. First, if you simplify, you get x cubed plus 9x. Differentiating, you get 3 times x squared plus 3. So if you integrate, okay, so differentiating gives you this. Integrating should give you back the same result. So if I integrate 3x squared plus 3, you get this. X squared, x times x squared plus 9. Don't forget the integration constant plus c. Okay, example 2. Integrate the following with respect to x. Okay, now let's just do all of this. Again, not very difficult. So if you remember, okay, what we need to do is to do the index plus 1. So integrate x cubed with respect to x. So what I get is index plus 1. 3 plus 1 is 4. Okay, and then what I need to do is to divide by the new index. So it's x to the power of 4 divided by 4 plus c. Not forgetting my integration constant. For part B, what I can do is I will simplify part B. 1 over x cubed can be rewritten as x to the power of negative 3. So I'm integrating x to the power of negative 3 with respect to x. Same thing, index plus 1. Negative 3 plus 1 is negative 2. So I divide by the new index, which is negative 2. Integration constant is plus c. So I get is negative 1 over 2 x squared plus c. Now, part C, okay, root of x. So root of x can be rewritten as x to the power of half. Integrating x to the power of half with respect to x. Half plus 1 is 3 over 2. Then I divide by 3 over 2, okay, plus c. Now, when you divide by a fraction, you just take the reciprocal. So y, okay, see here, 1 divided by 3 over 2 is equals to 1 times 2 over 3. Hence, okay, for this question here, what we get is 2 over 3 x to the power of 3 over 2 plus c. Okay, do pause the video for try 2, alright, and do attempt these questions to see if you have mastered the basics of integration. Okay, for part A, again, the index, you add 1, divide by the new index, then plus c. Similarly, for part B, you re-express this as x to the power of negative 4, index plus 1, divided by the new index, and you get negative 1 over 3x cubed plus c. Similarly, cube root of x can be expressed as x to the power of 1/3, power plus 1, then you divide by the new power. Okay, this one, just let me help you out a bit here. X to the power of 1 plus 1/3 is 4 over 3, divided by 4 over 3 plus c. So 1 divided by 4 over 3 equals to 1 times 3/4. Hence we get 3 over 4 x to the power of 4 over 3 plus c, which is what we have here. Now, okay, if I have an integral, okay, so what this means is this: if, okay, I were to have, for this one in simple terms, okay, is this: if I were integrating, let's say 5x to the power of 2, okay, with respect to x, instead of integrating 5x to the power of 2, I can actually factorize the 5, okay, I place it, okay, and then I just integrate x squared with respect to x. So what I get is 5 times x to the power of 2 plus 1 is 3 divided by 3 plus c. I get 5x cubed over 3 plus c. This is what it means by I can actually factorize out the constant itself. This second line means that if I were to have multiple terms when I'm integrating, you can integrate each term separately. If it's separated by each term is related by a plus or minus. So, for example, if I have x plus x squared with respect to x, if I were to integrate this, I will just integrate them separately. So I integrate the first one, okay, I'll get x to the power of 2 over 2 plus x, I'm integrating this guy now, x to the power of 3 divided by 3 plus my integration constant plus c. So it's similar to differentiation, where you can differentiate each term. So in this case, when you are separated by a plus minus operator, you can also integrate them separately. Okay, what better way than to show you? Okay, now, if I were to integrate 2 over x cubed with respect to x, what I can say is I factorize 2, I'm integrating x to the power of negative 3 with respect to x. So now, what I have here is x, negative 3 plus 1 is negative 2 divided by negative 2 plus c. So if I just eliminate 2 and 2, so I have negative 1 over x squared plus c. Similarly for part B, if you integrate 8 with respect to x, here's something interesting. Okay, if you integrate 8 with respect to x, the answer is just 8x. But how do I get 8x? Let me show you now. What you're actually integrating is 8 x to the power of 0. X to the power of 0 is 1. So what we have here is 8x. 0 plus 1 is 1 divided by 1 plus c over here like this. So if what I will get is 8x plus c. So this is something that is quite important that we need to learn, okay, in sense that when you're integrating a constant, you just add in the x. So for example, okay, if I am integrating 5 with respect to x, what we get is just 5x plus c. So if let's say I just expand your knowledge a bit further, if you have negative 7, you're integrating with respect to t, what I get is negative 7t plus c. Okay? Now, can you please try 3, pause the video. These are quite simple questions and we are done. Please unpause the video and we can carry on. Okay, so 5 over square root of x can be rewritten as 5 times x to the power of negative half. Rinse and repeat, negative half plus 1 divided by half, and you get 10 x to the power of half plus c. Similarly, if you integrate 2/3, okay, it's 2/3 x plus c. Okay, example 4. Find the following definite integrals. Okay, so now what we're going to do here is this. I'll do part A and part B, C, D, and then you will try. Okay, so part A. Integrating x cubed plus 2x, okay, with respect to x. Same, x, 3 plus 1 is 4 divided by 4 plus 2. X to the power of 1 plus 1 is x to the power of 2 divided by 2 plus c. So we get 1/4 x to the power of 4 plus x squared plus c. This is example 4a. Now, in order for us to do example 4b, okay, so what we get is the integral of 2x times 2 minus x. Okay, so the simplest way is to just simplify. We expand the brackets first. 2x minus x squared with respect to x. What we get here is 1 plus 1 is 2 divided by 2 minus x. 2 plus 1 is 3 divided by 3 plus c. Simplifying this, we get x squared minus 1/3 x cubed plus c. for 4b. Okay, let's move on to 4c now. So 4c, same thing also. First, we will simplify. X cubed over x squared simply gives me x. 1 over x squared is x to the power of negative 2, integrating with respect to x. So 2 over 2 minus negative 2 plus 1 is negative 1 over negative 1 plus c. So I get is half x squared plus 1 over x plus c. Okay, part D. So part D, same thing. If you were to simplify, 2x squared over square root of x is 2 to the power of x. 2 minus half is 3 over 2 minus x. Power 1 over half is x to the power of half respect to x. So now, first, power plus 1. So 3 over 2 plus 1 gives me 5 over 2. So divided by 5 over 2 minus x. Half plus 1 is 3 over 2 divided by 3 over 2 plus c. So down here what we get is 2 divided by, okay, watch this one. 2 divided by 5 over 2 will give me 4/5 x to the power of 5 over 2 minus 1 over 3 over 2 is 2/3 x to the power of 3 over 2 plus c. And that's it for my example 4. Now please pause the video, try 4. Okay, once you're ready, please unpause the video and we can go through try 4. Okay, for try 4, it goes like this. For the first one, what we do is negative x squared plus x. Simple enough. Power plus 1 divided by the new index. Here, power plus 1 divided by the new index here. And you get this. For part B, it will be prudent to expand this first. X squared plus x plus 2x, so you get plus 3x. 1 times 2 is plus 2. You integrate 2 plus 1 is 3 over 3. Here, similarly, 1 plus 1 give me 2 divided by 2. Integrating a constant, you just put the x. Don't forget the integration constant plus c. Part C, similarly, you simplify as what I've done in my example. 2x squared over x squared gives me 2. 3 over x squared can be expressed as 3 times x to the power of negative 2. Integrating 2 gives you 2x. 3x to the power of negative 2. Negative 2 plus 1 is negative 1. Divide by the new index, negative 1. You simplify to get this. Similar to this, x cube root of x can be rewritten as x to the power of 1/3. So 3x squared over x to the power of 1/3 will give me 3 times x. 2 minus 1/3 is 1 and 2/3. So it's x to the power of 5 over 3. Hence, this is x to the power of 5 over 3. 2 over x to the power of 1/3 is 2 times x to the power of negative 1/3. So if you do the integration, 5/3 plus 1 divided by 7 over 3, then negative 1/3 plus 1 is 2/3 divided by the 2/3, you will simplify to get this result here. Okay, now example 5, then try 5 and we will pause here and then I will continue this chapter or this sub-chapter rather in part 2 of this video. So for example 5, first they will ask that we differentiate this what I call expression here and then hence or otherwise find the integral. So what we'll do here is this, part 1, differentiating square root of 2x minus 1. 2x minus 1 can be re-expressed as 2x minus 1 to the power of half divided by 2. So first, the half, I will, this is application of chain rule. So it's half times 2x minus 1. Half minus 1 is negative half. Then I differentiate inside the bracket. 2x minus 1 simply gives me a 2 divided by a 2 here. This 2 is this 2. So if I have done everything correctly, what I get is 1 over 2 times square root of 2x minus 1. Hence or otherwise, find the integral of this. Okay, here is where the hence will come in very importantly. Without this hence, actually, I'm not too sure how we're even going to solve this. Okay, so now what we're going to do here is this 1 over 2. So theoretically, if I integrate 1, okay, over 2 square root 2x minus 1 with respect to x, since I differentiated this, I've gotten this. Agree with me? So therefore, if I integrate this, I should get back the original expression there. So what I can say is I'll get square root of 2x minus 1 over 2. Then don't forget my integration constant plus c. Hey, but you notice that they did not ask us, okay, to integrate this. What is the difference between what I've written down and what they want? So if you notice here, it's just 1 over square root of 2x minus 1. What is different between this and this? Can you spot the difference? The difference is the constant 2 here. So if I want to eliminate this constant 2, what can I do? I can multiply the expression by, or the integral by 2. When I multiply by 2, okay, what happens is I can eliminate the 2. So once again, to make this and this equivalent, what I can do is multiply by 2. So this 2 and this 2 will eliminate each other. However, since this and this are equivalent, if I multiply by 2 here, I must similarly multiply by 2 on my right hand side. You could also multiply c by 2, but it's a constant that is unknown anyway, so we typically do not write 2c there. So now I will write using blue color. I multiply by 2. Remember why I did that? So that I can make this and this equivalent. So when I do that, I also multiply by 2. Don't bother multiplying the c by 2. By right, it should be a 2c. But as I say, it's a constant anyway, which is unknown. So when you do that, you can write for the next line, square root of 1 over square root of 2x minus 1 with respect to x. 2 and 2 eliminates to simply give me square root of 2x minus 1 and plus c. And I'm done with example 5. So do try 5 and pause the video. When you're ready, please unpause this video and we can speak about the answer to try 5 itself. Okay, so for try 5, what we have here is this. If I differentiate this, power half, I bring down my power half. Half minus 1 is negative half. You differentiate 4x minus 3, you get 4. Okay, down here is 4. So you simplify 4 and 2, you get 2. So it's 2 over square root of 4x minus 3. Then, if you integrate this, you should get back to this. So now I integrate this, I get back to this. However, the difference between this and the question is the constant here is 1, the constant here is 2. Okay, so now, okay, what I can do here, I think I don't quite like this working here. So, okay, let me rewrite this. So, if I were to integrate 2 over square root of 4x minus 3 with respect to x, I would get back square root of 4x minus 3 plus c. Like this. Okay, but what they want me to integrate here, there's only a 1 on top. So if there's a 1 on top, how do I make this equivalent? I will need to get rid of this 2 here. How to get rid of the 2? I multiply by half. How does that help? 2 and 2 will eliminate to give me 1, like this. So if I multiply by half on the left hand side, by equivalence, I must multiply by half. I will not bother multiplying c by half because it's just a constant anyway. So my next line would be you integrate 1 over square root of 4x minus 3 with respect to x. What we get is half square root of 4x minus 3 plus c. And we're done. Okay, That's it for part one of